Hello, my name is Amin Soltangheisi, and today I'm going to talk about the effects of mycorrhizal symbiosis on the partitioning of copper in poplars. Contaminated land surrounds numerous mining towns in the copper belt of Zambia. As mining activities decline, communities are left jobless and heavily impacted by the negative environmental and social conditions surrounding them. The challenge is to understand and promote an effective revegetation approach using plants that are economically productive, providing employment, diversification, and renewable energy. Phytoremediation is the use of plants and their associated microorganisms for environmental decontamination from which phytoextraction is considered to be useful for inorganic contaminants. It's an in situ technique that preserves soil structure and microbial activity, offering protection against erosion. Fast-growing trees such as poplars may have potential in phytoremediation schemes. Their symbiosis with arbuscular mycorrhiza can alter element uptake, distribution, and toxicity. We used a sandy substrate to conduct dose-response experiments to observe copper uptake dynamics. Plants grew for 4 months to establish above-ground biomass in response to copper availability ranging from no added copper to beyond soil copper concentrations observed at the mine site. Besides that, the effects of two different arbuscular mycorrhiza species of Rhizophagus irregularis and Paraglamus lacetum on copper uptake were investigated to see whether mycorrhizas can help poplars to tolerate very toxic concentrations of copper. We observed that total copper uptake by poplars was only influenced by copper concentrations. As expected, total copper uptake increased with increasing soil copper application. Shoot and root copper uptakes were influenced by the interaction of mycorrhiza and copper concentrations. Mycorrhiza influenced shoot copper uptake only at the highest copper concentration. At that level, Rhizophagus irregularis resulted in the lowest and Paraglamus lacetum resulted in the highest shoot copper uptake. Mycorrhizas impacted root copper uptake at the highest concentration of copper application. Rhizophagus irregularis resulted in the highest root copper uptake, while Paraglamus lacetum did not influence root copper uptake compared to non-mycorrhizal treatment. Shoot copper uptake increased with increasing copper concentration under all mycorrhizal treatments, but root copper uptake under Paraglamus lacetum and non-mycorrhizal treatment did not increase with increasing copper application from 729 to 6,561 mg per kilogram of soil. We conclude that the impact of arbuscular mycorrhiza symbiosis on copper uptake in poplars depends on their species. We also observed that arbuscular mycorrhiza did not influence the overall copper uptake, but its partitioning in poplars. Thank you very much for listening.